All right, we're all pretty used to AI that can talk, right? But today, we're going to talk about the next big leap, AI that actually acts. We're digging into the big question here. How do we turn a great conversationalist into a doer? How do we get these large language models to go from just answering questions to actually getting tasks done? Let's jump in.
We've all been there. We use chatbots to find stuff, summarize articles, answer our questions, and they're amazing, no doubt about it. But there's a limit, isn't there? They're great at talking, but they can't really do anything. They're conversationalists, not actors. So what's the next step in this whole evolution? Well, the difference really boils down to one word: action. Think about it like this. A chatbot might be able to find you the details of your company's insurance policy. Super helpful. But an AI agent, it could take that info and process an entire claim from start to finish. We're talking analyzing documents, checking for compliance, even calculating the payment. It's the jump from passively finding information to actively executing a task.
This quote just nails it. A standard AI, like a RAG system, is like a world-class librarian. Seriously, it can find you any piece of information you could possibly need. But an AI agent, that's the entire research firm. It doesn't just hand you the book. It reads it, writes the report, builds the presentation, and then, for good measure, puts the meeting on your calendar. Big difference.
So, what gives an agent this superpower? It's not magic, I promise. It's all about a very specific architecture. So let's pop the hood and take a look at the three core parts that really make an AI agent tick. Okay, first, at the heart of every single agent, you've got its brain, a large language model, or LLM. But in this case, the LLM isn't just spitting out text. It's acting as a command center, a cognitive engine. It thinks through a problem, it comes up with a strategy, and it breaks a big, messy goal down into a series of smaller, doable steps. This is where all the thinking happens. Next up is memory. And this is what allows an agent to actually learn and get better. It has short-term memory, to keep track of what you're talking about right now. But the really crucial part is its long-term memory. It can store lessons from past jobs, which lets it personalize what it does and, honestly, get smarter over time. And this is the real game changer, the toolkit. This is what connects the agent's brain to the rest of the world. A toolkit can be anything: a web search, access to a database, the ability to use an app's API. These tools are basically the agent's hands, letting it actually do the things its brain comes up with. Of course, not all agents are built the same. They exist on a whole spectrum of complexity. So let's kind of visualize this by climbing what I like to call the agent ladder, starting with the most basic and going all the way to the most advanced. So at the very bottom rung, you've got simple automation, just following a script. Take a step up, and you get the reasoning agent. This is where it starts to think and act to solve problems using frameworks like React. Then, another step up, you have the grounded agent. It does everything the reasoning agent does, but it also pulls in outside info to fact-check its own work. And then, at the very top of the ladder, you have a whole team of agents, all working together to tackle a huge goal. Now, this brings us to a huge design choice you have to make. Do you build one single all-powerful agent, or do you build a team of specialists? A single agent is way simpler, right? Easier to build, easier to manage, but it can get bogged down or confused when a task gets too complicated. A multi-agent system, on the other hand, is amazing at handling complexity. It can do multiple things at once. The catch? It's a lot harder to build, a nightmare to debug, and just generally more complex to coordinate. So let's say we go with the team approach. How do we actually get them to work together effectively? I mean, you can't just throw a bunch of agents into a digital room and hope for the best. You need a structure. You need a game plan.
The thinking here is actually pretty simple. Specialization works. It's just like building a real company. You wouldn't hire one person to do everything, right? You build a team with special skills: finance, marketing, sales. The exact same idea applies to AI. By giving agents specific jobs, they perform way better than one generalist agent trying to do everything. One really common way to do this is with a hierarchical pattern. Think of it like this. You have a supervisor agent that acts as a project manager. It gets the main goal, breaks it down into smaller pieces, and then hands those tasks off to specialized worker agents. It's a really clear top-down structure. Another way to go is the sequential pattern. This works exactly like a digital assembly line. The first agent does its job, and its output becomes the input for the next agent in line, which does its job, and so on. It's perfect for any process that has a clear step-by-step flow. And this kind of structured work has massive real-world implications.
And to really get a feel for that impact, just look at this number, 71%. What do you think that represents? 71%. That's how much time sales pros spend on admin work, stuff that isn't actually selling. Just let that sink in. Now imagine a team of AI agents handling all of that, updating the CRM, drafting follow-up emails, scheduling the meetings. This frees up your human experts to focus on what only they can do, building relationships and closing deals. That is the real, practical power of this stuff.
But, and this is a really big but, building agents that actually work well is incredibly hard. For every success story you hear, there are a ton of projects that just don't deliver. So let's get real for a minute and look at the most common reasons why they fail. Oh man, there are so many ways this can go off the rails. The agent might just fail to come up with a decent plan in the first place. It might misuse its tools, trying to use a screwdriver like a hammer. It can get stuck in a loop, just repeating the same failed step over and over and over. They can get ridiculously expensive to run. And maybe the toughest challenge of all, it's really, really hard to even know if an agent is doing a good job. And that brings us to the most crucial point. Success isn't just about building the agent. It's about building a system to constantly check its work and make it better. I mean, look at this chart. An agent with no evaluation? The performance is pretty bad. Add some basic metrics, and okay, it gets a little better. But look what happens when you have a continuous feedback loop, where you're constantly testing and refining. Performance just skyrockets. An AI agent is only as good as our ability to evaluate it. And that's really where we land. AI agents are this huge shift, moving us from AI we just talked to AI that can be an active, autonomous partner. The potential is absolutely enormous, but the real challenge isn't just building them, it's building them the right way, with solid planning, reliable tools, and just relentless evaluation. The power is right there for the taking. The real question is, are we ready to do the hard work it's going to take to earn it?